Okay, so we have a patient with a pH of 7.33. We have a bicarb of 22. And we have a CO2 of 55. What condition do we have? Respiratory acidosis. Okay, one little mnemonic, I think is a mnemonic that you have for figuring out your acid-base problems when they're basic acid-base problems. You roam, and so that means you have respiratory is opposite and metabolic is equal. And so what you're looking at your arrows. So we have a pH is it high or low? It's low. Your bicarb, is your bicarb normal? So we can put okay right there. And then your CO2 high. So we see respiratory, our arrows are opposite. Okay? So that's an easy way to figure out your acid-base problems. Let's do a couple more. Okay, so we have a pH of 7.47, a bicarb of 28, and a CO2 of 34. We have, okay, so our pH is a high or low? High. What about our bicarb? It's 28. Okay. What about our CO2? It's 35 to 45, so it's really this one is okay, but I'll go ahead and put 35. Okay, so we'll say that's okay, that's normal. Okay? So we've got metabolic alkalosis. Okay. Okay, a pH of 7.32, a bicarb of 28, and a CO2 of 44. Let me make sure I'm looking at this right. 35 to 45. That's, if I'm looking at this right, let me step back. Okay, pH is it high or low? Low. Okay, our bicarb is high. Okay. And CO2 is okay. All right. So we've got what? This is metabolic. Our HCO3 is 28.
But, okay, if you do the arrows opposite, then it's respiratory.
Well, what did I do wrong?
Isn't it respiratory acidosis?
I'm doing something wrong then. Let me check it out, y'all. Hold on. Something can compensate, but we hadn't even gotten to that part yet.
There is no, the acid can be low and the carbonic acid be high. It can be, the first two are wrong.
Well, if I tell you that little mnemonic thing, that wouldn't work for this one. I mean, this can exist, but,
The bicarbonate is an alcohol, so it shouldn't go that direct. It will be low like that.
But if you have compensation, and I'm thinking that's what I did, I put a compensation one up. Okay, so let's go past that one, because we're going to talk about compensation, so that was the wrong one to put up, y'all. Sorry. Don't want to throw you off. Well, let's talk about compensation. Okay, so with compensation, we talked about that a little bit with two of the problems. Well, inside of the little PowerPoint. With compensation, that means that we have either the lungs that are attempting to fix the situation or the kidneys that are attempting to fix the situation, fix the pH level. So when you have problems like problems like this that I was putting up on the board, if it were a test question, both your bicarb and your CO2 are going to be out of range. When you're doing these, though, when you're looking at problems, looking at the pH, the bicarb, and the CO2, one of them is going to be more out of range. Okay? Example, like the bicarb, if it was a respiratory problem, the bicarb will be a little bit out of range because the bicarb is the latest to respond. Okay? So if I were giving you a problem like this and both of them were out of range, you've got to look at them. One is going to be more out of range than the other one. Okay? And so right now, since we're just beginning fluid and electrolytes, you have partial compensation and you have full compensation. That's a little too much for us to get into in this class. We'll get into that a little bit later. So your questions that you may see would be, let's just say, maybe with the last one, all you selected was, let's say, respiratory alkalosis. If that were what you chose and I had respiratory alkalosis with compensation, the with compensation would be the correct answer. Okay? Respiratory alkalosis alone would not be the correct answer because you've got the other one, you've got the, say, respiratory alkalosis, you've got the bicarb trying to adjust for that respiratory problem. Do y'all understand that? Okay. Go ahead. Kinda. Okay, let's talk after class. Let's go over these questions really quickly. Okay. Can you all see this in the back? The next time we have class, I want everybody to look where they are right now. All my people in the back are going to shift to the front, and everybody in the front shifting to the back. What is the best explanation for why changes in blood pH reflect the adequacy of acid-base homeostatic mechanisms? Okay, so how many people think that A is the answer? Okay, couple hands. Okay, B, C, and D. Okay, so I'm either going to assume that y'all can't read it or what's the issue? Let's just try it. Let's just try it, okay? The body fluid pH is a measure. A says the body fluid pH is a measure of the blood hydrogen concentration and the acid-base homeostasis mechanisms control this concentration. Let's go to B. Body fluid pH is a measure of the blood bicarbonate concentration. Is that what pH is a concentration of? So we can go ahead and cross B out, right? Okay. When homeostatic mechanisms are functioning properly, the blood electrolyte concentrations are normal as measured by the pH. Does the pH measure electrolytes? No. So we can go ahead and cross C out, right? When the body fluid pH is normal, acid-base homeostatic mechanisms are not needed.
That's what keeps it normal. That's a regular.
The pH is what keeps it normal. So we can cross D out, right? So what's the answer? Thank you. Okay, so let's just take the question apart again if we can. What is the best explanation for why the blood pH reflects acid-base homeostasis? If the words are throwing you off, let's just work with it, okay? If you're having a problem with questions like these, do like we just did. Go and pick out the ones where it's just wrong, okay? Did you understand why B was wrong? You understood why B was wrong? Okay. So did you understand why C and D were wrong? Okay. But it was all after we went over it. Okay. So are y'all going to take y'all time and read? Because these are the types of questions that we're going to have on the test, okay? So that's why I want you to get in the habit of really reading a question and see what it's asking you. All this question is asking you is what determines how pH is, what determines how pH functions in the body. And we know that the hydrogen concentration has everything to do with calculating the pH, okay? The client has severe respiratory impairment. Which alterations in acid-base balance could be expected as a compensatory response? Decreased arterial blood pH, increased arterial blood bicarbonate, C, increased arterial blood oxygen, or D, decreased arterial blood carbon dioxide. Okay, so we got a couple of answers out there. Okay, so how many think it's A? It's the pH, decreased arterial blood pH. Okay, what about B, increased arterial blood bicarbonate? Okay, what about C, increased arterial blood oxygen? Okay, D, decreased arterial blood carbon dioxide. Okay. Now, this person has a severe respiratory impairment. If I have a severe respiratory impairment, something's going to be wrong with my breathing, right? Okay. So we know carbon dioxide is our problem then, right? Is it an acid or a base? So we only working with two systems, right? The lungs and the kidneys. So we're talking about compensation in this problem. So if we already have a problem with the lungs, what's left to compensate? The kidneys. So the answer for this one is going to be B. Okay, it's going to be increased arterial blood bicarbonate. We need more bicarbonate because we've already got a lot of acid if the person has a respiratory problem, right? They've got problems with the carbon dioxide. Okay?
Of the respiratory impairment, but that would not be the compensation. That's what that question is.
It says a compensatory response, so it's happening this is happening as a result of the person having that. Okay. Which acid-base imbalance should the nurse be most alert for when providing care to a client who has several broken ribs? Respiratory alkalosis from anxiety, respiratory acidosis from inadequate ventilation, metabolic acidosis as a result of calcium loss from broken bones, or D, metabolic alkalosis as a result of ingesting base-containing analgesics. B is in boy? Okay. Okay, B is going to be the correct answer. We have a patient that has several broken ribs. And let's just think about having broken ribs, right? It's bone. So every time this person breathes in, it hurts for them to breathe. So chances are they're going to breathe, but they're going to take really shallow respirations, okay? So because of that, that person is going to have a lot of what? Acid. CO2 or acid. And so they're going to be retaining CO2, so we have respiratory acidosis from inadequate ventilation. Do you have any questions about anything we've talked about so far? Go ahead.
Okay, my question is,